So let's explore this chapter 2 Jupyter Notebook. And if we go to if we look at this, a couple things that we can note. Um, One, there's this import statement, and if you're using Visual Studio like this, Visual Studio Code, it says it could not resolve Pandas, NumPy, Matplotlib, sklearn. So these are all machine learning libraries that we're going to use to do this. And normally we would have to install all of these one by one, just like you would have to install any library before you can use it. We can do this all at once, though, because in the files that you download from the book resources, there's a requirements.jupyter.txt. So I'm going to add that to this folder here. And if we look at that, we'll see that it has a list of all the libraries we need to install. Now we could go through and pip install each one of these one by one, but the nice thing about having this is that we can open up a terminal here. And if I do a dir, you'll see that when you open up a terminal in Visual Studio Code, it opens it up to the directory where you're working, which is kind of nice. And we have that requirements Jupyter.txt, and we can install all of those at once by doing a pip3 install -r requirements, and we're just going to put in the name of this file, requirements_Jupyter.txt. So this is kind of a quick way in Python to install a number of libraries all at once. And I probably I misspelled it. It's with a Y. Requirements, Jupyter.txt. See if I spelled it correctly this time. And now it's pulling down all of those packages and installing them all at once. So this way we don't have to do 5 or separate pip installs. It just loads them all at once. So any text file which has the name of the libraries, pip install will just grab them, and you can reference the text file to do the download. So great, that should install. If I look now at at that file, let's see if that resolved all of those. We'll run this and see what we get. It might be also which version I'm running. Let's try this one. That looks a little better. So if you have multiple installations of Python on your computer, this clicking here will allow you to pick the one that you're using. Okay, so it looks like it did all of these installs. And now the next thing that we're going to look at is this piece of code here. This is basically, I manually downloaded and pulled the library into this folder here, and I could actually just change these two read statements to point to this folder location. But this is interesting because what they're doing is they're putting a URL for where this folder that we got it was, and then they are saying, and then they're using URL open to open this this website, and then they are reading this as a file and extract it. So if you want to automate the process of using a zip file, you can do this, and you can actually go out. So there's doing two things. They're going out to the web to get that. They're using Bytes.io to read that file. This is basically just, or actually this is just the regular file read command that you learned in the first iteration of this in Python 1. This is just a regular read command. Brings this back as a string. They're passing it to Bytes.io, which returns a featureless instance of the that has, yeah, so it's cleaning up this file, and then they're using zip file. And what zip file does is it actually takes this zip. It actually, since this is a zip file that we're reading, this will actually allow us to extract. So taking the string, turning it, recognize it as a zip file, and then we can call the extract all and store the extracted files, and they're putting it in this temp folder. So let's run this section of code and see what happens. And so we have a temp file. Let's see where we can find that. And it ends up on your C drive. So if you go to your, after you run that piece of code, you go to your C drive, you'll find it ends up here, which I don't really appreciate too much because it kind of clutters up my C drive, but that's okay. But you can see that it extracted it here. So we kind of have this here and here right now. And that's okay. So we're really actually going to be drawing, we're not going to be using this one at this point. We're going to be using this one. Now, if that didn't work, it gives you, note if you have an error, then what you can do is just change this reference to point to this file. And it should just be actually, because it's in the same directory, you should, if I wanted to use this one, it would just be, I just get rid of the temp. Or I would, I would have to get the path to that, and I'd have to put that in here, and then it would grab it directly from here if I did that. So you can just copy the path in and grab the version that you downloaded. But if this works, then you don't really need to do that. So the next piece of code they're demonstrating is this describe function. Describe is a method that belongs to this to the CSV file. So Bytes.hour.df raw is a data frame object. Data frame, I believe, comes from one of these libraries. I'm not sure if it's pandas or which one, but they provide us a describe function. And if you run this one, what you'll see is it's saying, let's run, it's running describe, and you can see that here it's taking our CSV file and it's pointing to temp. Well, what's temp? Well, temp is, if we go across here, it's this column of data. And they're taking it off of the hour one. And so what Describe does is it just runs it does a few statistics on it, and it's telling you that there's 17,379 rows of data, that the mean value on temperature is 0.49, which you kind of expect because we are taking the remember when we looked at what the temp was, it was a value between 0 and 1. It's a decimal value between 0 and 1, which represents where that temperature fits on the maximum values. And then we get the standard deviation, the minimum value, and the maximum value. So 2.2 and 1. And then at the 50th percentile, what the 50th percentile value is, which is 5, what the 25% value is 3.4, and what the 75% value is 6.6. So this is actually kind of describing the normal distribution curve. The next function that they have on here is the head function. So again, we're using our bikes hour raw variable, which is basically has read in this CSV file, and let's run that and see what that looks like. And we can see that what it does basically is it gives you the first 5 elements or first 5 rows of the data. And this is useful just so that you can explore the data without having to roll through the whole thing. So a lot of these functions are basically, they're not things that you necessarily would use programmatically a lot, but you can use them in the context of something like this to just kind of explore the data. And then here we're going to look at this is the one bikes by hour, and this is bikes by day. So we can run this one, and if we look at the two pieces of data together as much as possible, we can see pretty much the same elements, although rather than hour, because if we're doing it by day, we just have year, month, and here they have year, month, and hour. So that's primarily the only differences we have with these two data sets. Now the next thing we're going to look at here is this drop function. And if we look at this data, we may decide that for our purposes, for what we're going to be doing with this piece of code, let me try to minimize this a little bit so that we can see more. We may not really need a casual registered. We're interested in the count, but we're just trying to predict the count. We don't really care necessarily. We're not trying to predict how many people will register and how many people will just come up casually. So we can actually use this to drop a couple columns. And so we'll do this. And this won't show anything initially. And then let's see, if we look at the bike info, we can see now that those two columns are no longer in this and you can see that what we did is we took the raw data that we had, we dropped these two, and then we stored the result in another variable, which is just bikes hour df. So we're still keeping the existing In fact, if we change this, for example, to raw, and run this, it has casual and registered still in it. But the variable that we stored the version with it dropped doesn't have those two values. So this is just a way of removing maybe columns we don't really want to work with. And then let's see, if I run this describe, we can see that now it's doing that same thing we did before. We ran this up here looking at just one column. If we just run it on the entire sequence, we get the count, mean, standard deviation, min, and all these pieces of information for all of those columns. And it has a continuation character because it can't fit this all in one line, but these are basically all the attributes of those of those pieces of data. So let's look at the description, the describe of this new bikes hour without the two. Well, actually, with just looking at the count row. So the count row is actually our outcome variable. So if you think of all the variables or all of the columns here, most of these are inputs, and the result is the number of bikes that are rented. So if these are input variables and this is the output variable, then let's take a look at that with the describe. And what we can see is, we have 17,000 measurements here, and this can be a useful way of looking at this because we can see that the average is 189 per day, or per hour, because this is by hour. And the standard deviation is 181. The minimum value is 1, and the maximum value is 977. Notice that the 50th percentile mark, it's 142. So you have some, 977 is a pretty good day. And so you don't have like a really super even curve here, but we can see that there are days where you get a lot, and then a lot of days where you get not so many. And then, and then you can look at, what the 25% level is and the 75% level. And this can kind of give you can kind of visualize what the curve is. And so, okay, so that's, what we're doing here is basically just getting a feel for the data. So this is the output. We know what the minimum and the max are. Those are probably the most useful things for us to think about at this point in time. And then another function that we can use is the subplots, as we can make a plot of this data. And so the subplots method returns a dictionary, and then we have the plot function. So we can take AX and the data that we get from this, and we can make a plot sorted by count. We're going to set the color of what we're looking at, and then we can and then we can set our Y label, and basically this will make a chart of our data for us. So what we're making a chart of is this count column in blue, And the marker is a dot, so it just ends up being a bunch of dots. And then this is the x-axis. We're not making the x-axis visible, so we're not showing the markers here. And then the Y label is set to have sorted rental counts. And we set the font size. And then a subtitle here is recorded count. So we can use this plot function to display plot. So you can use this with any data you want. And this is using PyPlot, matplotlib, and which is one of the libraries we imported that we can see above. So if we look at our import, matplotlib pyplot SPLT, and where were we? We were down here. plt.subplots is where we're creating that plot, and the documentation for that is here under matplotlib. So you can read up about using matplotlib, and I encourage you to play around with this and make different graphs. And that's what we're doing here. So we can see the data. So you can see that, there's some days where we have a really large number of rentals, and then most of the days it's kind of between this level here. So it's kind of this exponential looking curve. That basically there's some days where you have a lot of activity, and then there's a lot of days where you don't have a lot of activity. So this is useful just for visualizing our data and having a better understanding of it. The next thing we're going to look at are scatter plots. So in here, what we're going to do is iterate through the various columns of our table, and then we're going to basically, if it's a floating point number value, so we're going to go for type in bike hour types, and if the type is 64-bit, then what we're going to do is we're going to plot this on a series of scatter charts. And so what a scatter chart is just, you will see, let's just run it and we'll see what it looks like, is it basically takes your data point and takes all the data points and then plots them, on a chart that is, the dimension, number count of bikes, and then for the column that we're looking at, here we're looking at temp, and we can see that, and we can see where the data lies. Now, if we look at temp and atemp, we can see that it's kind of linear. It's low. If the temperature is low, then the count of bikes rented is low. If the temperature goes up, the average number of bikes that are rented goes up. So you could roughly imagine that a line here could represent the rentals. We can also look at atemp, and we can see that it's almost exactly the same, which makes sense. You wouldn't expect that wind speed would change the temperature enough to really change it. And so what we might say is, these two are almost duplicates of each other. We could probably drop atemp in our data and just look at temp to find the relationship. If we look at humidity, we can see it's just kind of a blob. It's not really super linear. We can see that if we get below certain humidity, the rental go down significantly. So there might be a relationship there. And then wind speed, we see if it's almost line with a negative slope, or we just note that over here when you get up to a certain wind speed, it kind of, people don't want to be cycling in too much wind. So that kind of makes sense. So all of these were called quantitative features because we were looking for columns here with our code that whose type was a floating point number. In other words, they had a value, that went from 0 to some other value. Categorical data basically is binary data. And so in this section, what they've done is they've written code to plot things that are categorical data, not necessarily just binary, but basically that, for example, the season. There's 4 separate values for season, spring, summer, fall, and winter. So we have a plot here of of the seasons, and then the other one, is the category of weather, which is clear, misty, light, or snow. So the category data is basically, it's not a numeric, from 0 to 100 or something. It's where we have separate independent categories that we're looking at. And basically they've just plotted it, and they're just plotting these in different sections because these require a little bit different treatment in the kind of plot. And so they're going to use bar charts for this kind of plot. So let's run that. And we can see the bar charts. And what do we note? Well, seems like we have a lot of rentals in the fall and the summer and winter. And it looks like it drops down, interestingly, in the spring. And then here we can see, based on the weather, if it's clear, that here it's clear, and when there's heavy rain, people don't seem to like to ride bicycles, or even in snow, not a whole lot of people interested in bicycling in snow. You have to be prepared to have your bike slide out from underneath you when you bike in the snow, and go into a kind of a Superman maneuver where you land on the ground, and it's not pleasant, but I'm not bitter. I survived. Anyway, biking in snow is doable but dangerous. And so, it's not surprising. We probably should use that in our data set because that's a pretty good indication. Here, yeah, and this does look like that it shows some influence on the results. And so basically what we're looking, in all of these things is, how does the input affect the output? So let's look at this next one. And here we're doing a plot of count, showing a histogram, showing basically the frequency of each different level of rental. And basically it shows how you have major outlier on certain days, and then it's kind of average. We got that from one of the previous plots. And then this is one where we're grouping based on the hour. So over a 24-hour day, it looks like clearly we have a peak in the morning around the 8 o'clock time frame, and a peak around the 6 o'clock time frame. So what could we ascertain from that? Well, probably a lot of people are renting bikes going to work and coming back from work, or before and after work. And after work is clearly the most frequent. But you do have a pretty steady amount during the middle of the day. It really drops off after midnight until the morning. And then by month, And then this is interesting. You notice that I believe this is January. And so in the winter it drops off, and then in the middle it picks up. So so we kind of would expect that. So that's just plotting the data. All those, well, everything we've seen up to now is just plotting the data. So you can take your data set and you plot the data, and you can look at the charts and at all the characterization of the average, the the standard deviation, all of that, just to kind of get a feel for your data. Um, but that's got a kind of limited that allows us to visualize our data ourselves by looking at it. But what we need is we really need a formula in order to programmatically be able to do predictions. For example, none of these charts or these things can be used by our computer program to do a prediction in and of itself. So that means that we need to learn to use something called linear regression, which we'll look at in the next section.